Today we will learn array of data structure. Today our topic is sparse matrix and its representation. Before learning this video, please learn our previous part of this video. This is part 2. Before learning part 2, please learn part 1 video also. So, we already learned in our previous part what is sparse matrix and what is its representation. And we already learned what is the utility of using this representation. So, what is sparse matrix? A sparse matrix is a matrix in which maximum number of elements are 0. So, this is an example of sparse matrix where maximum number of elements are 0. There is no precise definition of a matrix when it will be sparse, but one can apply common sense to recognize it. For a matrix of higher order, if it is sparse, it will be better to store only non-zero elements in order to save the space. One method to store the non-zero elements of the sparse matrix is the three-tuple form. So we want to store only non-zero element to save the space. So we use this representation, that is this three-tuple form. So in case of three-tuple form, we already learned in our previous video that first row is for this 3. This is total number of rows in this sparse matrix, that is 3. 5 is total number of columns in this sparse matrix, and 4 is total number of non-zero elements. Now, for 0th row and second column, the non-zero element is 1. So, I have to write 0, 2, 1. For first row and fourth column, the non-zero element is 3. So, I have to write 1, 4, 3. For second row and 0th column, the non-zero element is 2. So, I have to write 2, 0, 2. And for second row, third column, the non-zero element is 4. So, I have to write 2, 3, 4. In this way, we can represent a sparse matrix to its three-tuple form. Now, think how to get transpose of sparse matrix. Means if a sparse matrix is in three-tuple form, how to get transpose of that sparse matrix in three-tuple form. Transpose of sparse matrix. So this is an example of sparse matrix. Corresponding three-tuple form is this. It is total number of rows are 3, total number of columns are 4, and total number of non-zero values are 3. Now for 0th row, 0th column, it is 2. See, first non-zero element 2. For second row, second column, non-zero value is 1, and for second row, third column, non-zero value is 3. So, what is the transpose of matrix A? It is the transpose of A matrix. And what is the three-tuple form of this matrix? It is, see, 4 is total number of rows of this matrix, 3 is total number of columns of this matrix, and total number of non-zero values are 3. Now see, for 0th row and 0th column, it is 2. For second row, second column, non-zero value is 1. And for third row, second column, non-zero value is 3. Now compare three-tuple form and transpose of three-tuple form. See, row value is 3, column value is 4. Here, row value is 4, column value is 3. It is 0, 0, then 2, 2. Here also 0, 0, 2, 2. Next, see here, row value is 2, column value is 3. Here, row value is 3, column value is 2. So, each row and column value are interchanged with each other. Transpose of the sparse matrix in three-tuple form. How we can write the code? Before writing the code, first see the discussion. Transpose of the sparse matrix in three-tuple form. For this, I require two two-dimensional integer arrays. One is A array, another is B array. The size of the arrays are int A 23 and int B 23. See, always column values are 3 because both are in three-tuple form. Now see, row values should be column value here and column value should be row value here. So what is the value of star A plus 1 whole star? See here it is 4. So it should be star B plus 0 whole star. So here it is 4. Star A plus 0 whole star. What is the value of star A plus 0 whole star? It is, see here 3. It should be column value. So it should be star B plus 1 whole star. What is the value of star A plus 2 whole star? It is 3. It should be this value. So star B plus 2 whole star. So star A plus 2 whole star equals to 3. Also star B plus 2 whole star equals to 3. I assign this value here. I am taking one integer variable k. I initialize k as 1. Now I start one for loop for r equals to 1 or less than equals to star A plus 2 whole star r plus plus. What is the value of star A plus 2 whole star? It is 3. So this loop will execute 3 times. Row value should be column value here, column value should be row value here. Now see, first time, what is the value of r? It is 1. What is the value of k? It is 1. For the third row, what is the value of r? It is 3. And what is the value of k? It is 3. I am taking the third row to discuss with you because previous two rows, row values and column values are same. See, so r is 3, k is 3. So what is the value of star A plus 3 into r is 3? 3 into 3 plus 1. See here it is 3. It should be where? It should be row value. So it should be star B plus 3 into k is 3 plus 0 whole star here. And what is the value of star A plus 3 into r? R means 3 plus 0 whole star. It is 2. It should be column value. So star B plus 3 into k. K means 3 plus 1 whole star. That is 2. And what is the value of star A plus 3 into r plus 2 whole star? It is 3. So here it is 3. So star B plus 3 into k plus 2 whole star, it is 3. And every time for each row, you have to increase k also. C program to implement transpose of the sparse matrix in 3-tuple form. See the coding. So this is our program. There are two-dimensional arrays are required. One is for 3-tuple form of the sparse matrix. Another is for representation of transpose of 3-tuple form of the sparse matrix. Now see, you have to take only row of the input matrix because it is in 3-tuple form, so no need to take column values. Now take all the elements, okay? And this calculation we already discussed. After that, I have to print the transpose matrix in this way. It is in 3-tuple form. Now see, when I run our program, supply the row of the matrix. See here, it is 4. Supply the elements. It is 3, 4, 3, then 0, 0, 2, then 2, 2, 1, then 2, 3, 3. This is input matrix. And transpose of this matrix is, see, this is the result. Our next topic is sparse matrix addition. Two matrices are there in 3-tuple form. First one is A matrix and second one is B matrix. Now see, we already know that in case of matrix addition, the row value and column value, both values are same. So, how we can add? See, the resultant matrix is this. So, row value is 3, column value is 5, and I don't know what is the total number of non-zero value. I will write later. Now, these are the rules. Traverse through both matrices element by element. Insert the smaller element, one with smaller row, to the resultant matrix. If row values are same for both matrices, then insert the smaller element, one with smaller column, to the resultant matrix. If we come across an element with the same row and same column value, we simply add their values and insert the added data into the resultant matrix. So see this point, if we come across an element with the same row and same column value. First time, it is 0, it is 0, it is 1, it is 1. So same row and same column value, then we simply add their values and insert the added data into the resultant matrix. So we have to add this value and insert the added data to the resultant matrix. So it is 0, 1, 3. Next time it is 0, 2, 3 and 1, 2, 2. See here, insert the smaller element 1 with smaller row to the resultant matrix. So row is smaller. So just insert this element to the resultant matrix. So it is 0, 2, 3. Now next row, it is 1, 4, 3, 1, 2, 2. If row values are same, see here, row values are same. For both matrices, then insert the smaller element 1 with smaller column. So which one has smaller column? It is 1, 2, 2. So insert that element. So it is 1, 2, 2. Now compare 1, 4, 3 with 2, 0, 5. Smaller row. So I have to insert 1, 4, 3. Next compare 2, 0, 5, 2, 1, 3. Row values are same. Compare column values because 205, here it is 0 and here it is 1. This one is smaller, so I have to insert 205. Now 213, 21 minus 3. Row values are same, column values are same. Then I have to add these two elements and the result is 3 plus minus 3. The result is 0. If after addition we get 0, then no need to insert it into the resultant matrix. So ignore this value. And finally it is 223, insert 223. So total number of non-zero values are 6. So here you have to write 6. So this is the resultant matrix in 3-tuple form after addition. Now think how to write C program for addition of two sparse matrices using 3-tuple form. So this is your programming assignment. Write a C program to implement transpose of the sparse matrix using 3-tuple form. Our second assignment is write a C program for addition of two sparse matrices using 3-tuple form. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.